I'm Dick Taylor. I'm the director of the Institute, and we'll be chairing the first session and giving the first talk, so I kind of get to blather here for a fair bit before the real the real people start. I'm very excited about this year's edition because of the keynote speaker we'll have this afternoon, Pam Samuelson. She's on an airplane flying down kind of as we speak. If you were having questions about whether you should stay around or not for this afternoon, I really urge you to do that. So Pam gave a keynote talk at ICSE in San Francisco last year on the question of software patentability. And I thought it was articulate, interesting, relevant. She's clearly on top of the subject. And I asked her at the time if she'd be interested in coming down here and talking about software patents and intellectual property. And she agreed, so I had this set up quite some time ago. So I think you really, really like what she has to say. I think she was hoping that the Supreme Court would issue its ruling on the Alice versus CLS banking, but the Supreme Court has not yet issued its ruling on that, but I'm sure you'll hear about Alice this afternoon. And then after that, we're going to have a panel to talk about what to do. So if you're a budding software entrepreneur and you start a company and you've got some good ideas, what should you do? Should you try and patent your innovations, your inventions? Should you keep them as trade secrets, and how do you go about doing that? Should you worry about copyright? There's just a lot of choices there, and I think you're going to see a lot of, well, what do you think about that kind of stuff from the panel? Because I don't think the way is very clear here, so I hope we'll have an interactive session to really explore what the options are for protecting intellectual property. It's an interesting domain. But before we get to all that, let me tell you just a little bit about ISR. One thing that was just kind of in the works last year was the new ISR website. I think we had the look and feel and maybe previewed a few things on it, but over last summer and in the fall, there's just been a tremendous amount of things added to the website. So I kind of wanted to highlight a few of these things. As I said, it's new. There's just a tremendous amount of information on here. So on the research page, there's look at the number of areas down the left side. There's a blurb on each of the projects going on. You can follow them to go to a little more detail, get pointers off to the relevant details and people and so on. Under publications, there's the usual thing that you would expect of having all the tech reports on here, which is good. I mean, those are important resources. But one thing that I'm particularly happy about is the bibliography. So if you look, there's 1,100 entries in here. So these are papers by ISR affiliated faculty and students with links off to the paper, the Google Scholar references, the ability to export the citations for the papers. It's all there. So some papers are easy to get to on some of the digital libraries. Other papers are not so easy to get to. But if it's by an ISR author, you should be able to find it here. Under happenings, there's one page which has announcements on this kind of screen resolution. It's all linear, but it looks a little better otherwise. You can see kind of a weird picture of me that was taken at Christmas. But there was a UCI news article about my retirement. And mostly when people talk to me about my retirement, they say, it doesn't look like you're retired. What do you do there? why are you still wearing a tie, Dick? I have no explanation. But under hot research, you'll find the articles here that are in the print version of the ISR connector. So you should be familiar, with these. There's always a hot research article on the front page of that. Those are also included here. The other thing on happenings, there are student updates, which I want to bring forward a little bit. So the grad students here are very active and very successful in a whole variety of things. So whether it's a new internship or a publication or a grant, Allegria here got a travel award to go to ICSI in Hyderabad, India. It just kind of keeps going on and on, all the activities of the students here. So you might want to take a look at that. Speaking of the connector, I'll just show you that is also available on the from the home page here. And you know, since it's my privilege to write a message from the director, I just wanted to say just a little bit about this one. I had a tremendous amount of fun writing this article. I don't know if any of you read it, but this is one of those articles where when you publish it, I expected the University of California Thought Police to come after me. They're active, the Thought Police are out there, but in this case, I only got a few comments, but my focus here was healthcare.gov when that debuted, so to speak, and what it meant, though, for our community. And the thrust of the article is that the organizations that were responsible for the debacle of healthcare.gov, the lead organization is a CMM level 5 organization. And this CMM level 5 organization got their CMM 5 ranking 1 year before healthcare.gov debuted. And in fact, 1 month before healthcare.gov debuted, the head of that level 5 organization testified to Congress that we're all good to go. So, as I said at the beginning here, this is cringeworthy. I mean, whatever side of the aisle you come down on with regard to healthcare.gov, this is not something that speaks well to our community, or speaks well of our community, I should say. So you might want to read that. It gets bigger and broader because it goes on to the organization known as CMS, the Centers for Medicare and Medicaid Services. There's a National Academy of Sciences study of that organization more than a year ago, a report issued more than a year before healthcare.gov rolled out, and the recommendations were not followed, and the disaster that ensued was completely predictable by what the National Academies did. So anyway, so far the Thought Police haven't caught up with me, but you can take a look at that. So anyway, I'm very happy with this website. I think you'll find it a resource for a lot of different reasons. And I want to give special credit to Carrie Neese, and who really put in many hours to get this right. So in fact, I shouldn't say this, but if any of you have an organization that needs a website, Carrie's your person. She does websites for lots of organizations across the university and elsewhere. So anyway, thank you very much, Carrie. Okay, enough promotion of the website. Let me just give some thanks to the organizers for today. Debbie Broderbeck, whom you all know in the back there. Carrie, you mentioned. Sheila Hootie, who's out in the front there. Eugenia, is Eugenia in here? She must be.
Eugenia is running around setting things up.
Right, which is why you should all thank her for doing, for doing that. And if you happen to see Kiana Falla today, please wish her the best. Today is Kiana's last day with ISR. She's moving on to a new position at UC San Diego. So if you see her, be sure to wish her the best in her new position as she moves down south. Okay, with that, any questions about ISR, what we're doing, what's going to happen today? Because then I'll transition to the technical session and technical material. So a year ago, I gave an early version of this talk at this meeting. It had a slightly different title, but I thought I would revisit it for a couple reasons. I had the opportunity to develop this question of software ecosystems and the role that architectural styles have in them. To develop that talk for a keynote I gave at the Software Product Line Conference in Tokyo last summer, and then at the Asia Pacific Software Engineering Conference in Bangkok in December. And as a result of those two talks, I've had a lot of conversations about this with a lot of people. And so I kind of want to share my new thoughts there. But I'm also wanted to talk about this from the perspective of this theme of how you help new companies and startups. So over the years, I've talked with a lot of students and former students who have started their own software companies. And if you look around the university or get the university advertisements for things, there's always competitions for the new business plan competition, the best new technology in the Butterworth competition or this competition or that competition. And so there's, students are always interested in doing the next great thing, becoming the next Facebook or Twitter or Airbnb, whatever it is. And one of the conversations that I always end up having with students is, yeah, your idea is a great idea, go for it. What is your second product going to be? And they say, but didn't you, my idea is really great. Yeah, I know your idea is really great. Okay, after your really great idea is out there and everybody loves it, what's your second product? And then it gets into a long and rather vague and wandering conversation that usually doesn't go anywhere. And my contention is that if you're interested in a startup, maybe one of the first questions you should ask after your initial enthusiasm is, what's your second product going to be, or what's your third product going to be? Because the way product cycles work is you put your new product out there, people love it, maybe, hopefully, you get some revenue from it, but pretty soon you've saturated your initial market. So your revenue stream starts to go down because all the customers who love you have already bought your stuff. So what you want them to do is love you enough to buy your second thing. And if you don't have a plan up front about what your second thing is going to be, then things usually don't turn out quite so well after a year or two or three in the marketplace. So anyway, I got to thinking about these marketplaces and software ecosystems, and let me tell you a little bit about that and why I think architectural styles are important things for these ecosystems. So just to be clear about what a style is, it's just a bunch of choices that you decide to make, rules that you decide to impose, and you impose them on your developers, and you do this imposition of these rules, these things that constrain what you do, because at the end of the day, you expect to get some beneficial qualities as a result. So if you play by these rules, some good things are going to happen to you. Okay? You have to decide which rules you want to play by to get whatever benefits you want. Okay? So the title also talked about success, and I would say success often means a lot of different things to people. So for some people, it's simply decreased time to market or production cost. For students, especially students still in school, it's usually widespread use. It's, I want to be famous. I want to be known in the developer community as being the really hot developer, and my mark of how I know that I'm really the hot developer in my community is because bazillions of people use my products around the world. Other people have a much more straightforward 6-letter definition of success, which is simply profit. Fine, profit's good. Or it could be adaptability. It could be that just having an adaptable product is this notion of success. So I'm happy with all of these for the purposes of this talk and talking about the role of architectural styles in successful ecosystems. So if you're not familiar with the phrase software ecosystem, it's a little more recent to the community than product line, and they're certainly related. So product lines are focused on separate products that share significant technical commonality, and by having the shared technical commonality, you get some cost benefits. So the old example on this is Philips TV sets. iPhone family is clearly another example of that. An ecosystem is a little different. An ecosystem is focused on multiple organizations, and it's kind of how does this whole group of organizations work together for their mutual benefit. So I'll look at examples of this in detail in just a minute, but just think of everything that's built around Amazon, or everything that's built around Photoshop, or the Apple iOS. These are ecosystems. There's lots and lots and lots of companies who participate, and they all have a shared interest in each other's success. But there's things that make some ecosystems work a whole lot better than others. Clearly, though, in all of these, you have to have lots of things aligned. So for product lines, you have to have the sweet spot between being in the domain, dominating that, having appropriate business models and approaches, and then technology that gives you that great domain-specific software engineering success. But if you think about how product lines differ from ecosystems, as I mentioned, product lines, it's usually a single agency. It's usually a single development organization that's focused on a product line. They've got the technological goodies, and they just reuse them across multiple products. With an ecosystem, it's multi-agencies, multiple organizations who all have some kind of stake in their mutual success. In a single product line, you probably have a very clear and fairly narrow notion of success. Usually it's reduced development time. I can get my next product to market out sooner simply as a result of the fact that I've got this understanding in-house. I've got the goose that lays the golden eggs, and I'm going to keep pumping out the golden eggs. In the ecosystems, that's kind of a gross kind of analogy, isn't it? Ecosystems, since the success criteria vary so much, lots of different kinds of considerations come into play here. Well, the person who's kind of perhaps done the most to promote the phrase software ecosystem is Bosch. And this quote from him came from a few years back in which he says what he considers a software ecosystem to be. It's a platform of developers that all work together to satisfy their needs. So given that definition, here's some examples of platform-based ecosystems. Often it's one big vendor and then a lot of little hangers-on. And you can think of many examples of this. SAP is classic. There's companies all around the world built around the whole notion of somebody decided to go with SAP, and now they come along and help customize it or install it or support it as it goes along. Facebook, Salesforce, eBay, Amazon, the Amazon third-party marketplace, all the other vendors that use Amazon, it's a huge community there. AutoCAD, Autodesk, Microsoft, Flash, Photoshop, these are all examples of where there's clearly one big vendor and other people benefit from that. I would also point out, though, in these, the revenue model is biased towards the platform vendor. If SAP isn't there, then none of the hangers-on get any revenue at all. Okay? But the hangers-on can go away and SAP will still get revenue. So these guys always win, whether or not the third parties win also. So how do these platforms work? Often it's just with an API. This is kind of the simplest and cruftiest way of doing this, perhaps. And I would also say the bigger the vendor, usually the less elegant the APIs have to be. If you're the 800-pound gorilla, you can get away with having ugly interfaces to your product. But it works. Another way of doing this, another architectural style that supports this kind of platform model, which is the language interpreter style. Here, the vendor provides a language which is the basis for third-party extensions. You don't just have to use an API, they give you something that's really got some heft to it to enable you to do that extension. Great example, best example probably, is Visual Basic for applications, or you could say that Flash ActionScript is the same kind of thing. The companies do a great job of providing these excellent scripting languages, and that enables everybody to build on top of that platform. There's another way of doing it. This is API flipped around. So the vendor tells you what API you must support, and if you support that API, the vendor promises to call you under certain circumstances. And it sounds a little odd at the beginning, but that's how Eclipse works. But the nice commercial example of this is Photoshop. So there's, again, a whole world of Photoshop third-party developers, and they are dependent upon Photoshop calling out to them. So Photoshop sets the rules, here's how you do it, and the benefit is, hey, my app is going to get called and it'll do some kind of shading or smoothing or effect on an image. It's a very effective style for doing that. Okay, so those have been the warm-up, and now here's the question to you. So what architectural style do you think Apple has said is the single most important style for you to understand and abide by if you're going to build an iOS app?
User interface?
It has to do with user interface, but you have to give me the architectural style.
Client server?
Nope. MVC, model view controller. Right. Okay, so there it is. This is a snippet. That's not my words. This is a snippet from an Apple document in which they say the most important design pattern is model view controller. And they go on to explain that. If you don't know MVC, it's this way of keeping what's going on in the user interface consistent based upon what's going on in the application and the actions that the user takes. So it's a long-standing architectural style, been around for many, many years. But Apple singles it out as saying, this is the most important thing. You've got to understand this if you're going to play in the iOS app development world. I think they're slightly disingenuous in kind of putting so much emphasis on MVC, because if you look under the covers, there's a lot more that you really have to understand well if you're going to be a good app developer. You have to understand event notification, how events work in iOS. You have to understand the development frameworks, Cocoa and Quartz, and there's the Foundation framework, UIKit, Core Graphics, and so on. And arguably, I think even the Xcode software development kit has a style to it that you are highly motivated to avail yourself of. Event-based styles, there's other people who do that. TIBCO is a dynamite one there because of what they do in financial trading systems. But rather than kind of talk about more styles, I want to ask this question of what is a platform? Jan Bosch's definition of software ecosystems say that the ecosystem is based around a platform. So what is a platform? And my question here is GPS a platform? I mean, think of all the products that depend upon understanding GPS signals. What about aircraft transponder vectors? The ADS-B standard, for example. What about financial information? If you go into the financial world, there's this thing called FIX, the Financial Information Exchange Protocol. It's not really a protocol, it's a messaging standard, but it talks about how you describe financial activities. If you want to play in this world, you need to understand FIX. Okay, so what I want to do in the last kind of 5 minutes here is talk about decentralized ecosystems. So in contrast to the one big vendor with lots of third parties, and those third parties have to know what the style is in order to effectively play in that ecosystem. What happens in a world where there is no single big vendor, where you want many people to be able to participate, but there's no 800-pound gorilla in the room. So here there's, excuse me, multiple independent spheres of authority. This, if you want to think about what's an example ecosystem, e-commerce, healthcare, defense, space systems, power grids, there's all kinds of examples. And the other thing that's interesting about these kind of ecosystems is not everybody has aligned objectives. In fact, you want to participate in this ecosystem, but you'd like to participate a little more successfully than your competitor in the same ecosystem. You don't want your competitors to fail because you don't want the whole ecosystem to go belly up, but you just like to succeed a little better than the other folks in the ecosystem. So the presence of competition virtually guarantees that all the objectives are not fully aligned. And that starts to really kind of torque your thinking around just a little bit. So given independence, competing interests, inherent risk, what suffices as a sufficient platform? So you could say weak standards like fixed or GPS, or go even lower and simpler like something like TCP. But if you're looking for something substantive, what do? So the community's first answer was web services. At which point you should all go, oh dear. Okay? Because the first instance was SOAP over HTTP plus WSDL and all the other standards, and everybody kind of made obeisance to this, but wasn't very substantive, wasn't very successful, though it was widely used. Arguably, though, as enterprise service buses came along and brought in event-based interaction schemes, it got a little better on. Web services take two. All right, let's wave the UCI flag and say it's RESTful web services. Okay, so nice long quote here, but the whole idea is simple set of principles. It's a style, and if you know this style, know these principles, then life will go better for you than it will if you use the SOAP and WSDL world. So if you don't know about the RESTful principles, go read that book. But an example of users, people who really bought into this heavily, are Amazon's S3 service, IBM's bought into it, Oracle, and so on. So there's a lot of people who've made direct use of it. There's also things built on top of it. So Ajax and Rails are things that support a big ecosystem that rest upon the RESTful style. So here's Rails. So you have Ruby, a language, Rails, a platform, and it says you have to understand REST, you have to understand the language, and you have to understand, once again, model view controller. And if you do that, and you live in the world of certain kinds of web services, things go very, very, very well for you by abiding by these styles. So some were upwards of 200,000 websites are based upon this set of technologies which rests upon these styles. Well, things get nastier, though, with decentralized systems because of the inherent competition and risk. There's security and trust issues, adaptation requests. There's a lot that are demands, you would say, for this kind of world. That's been the focus of work that's gone on here with the Coast architectural style. So we've gone down the road of supporting these kinds of decentralized applications based upon mobile computations, communication constraints, a number of things. I'm going to skip this because I'm just going to take in the last minute here. This one point. One of the characteristics of Coast as an architectural style is that there's very strong regulation over who can talk to whom. But it's not just who can talk to whom, it can be for how long, under what circumstances, and about what. And the degree of control over communication, we believe, gives us the ability to have essentially, I have another slide here. Control over the revenue model to level the playing field there, so that for each interaction that you have with a third party, not only is it secure, but by being resource limiting, you can have very fine-grained controls over the revenue models. We'll see if this turns out to be true or not, but that's the goal. So where we are, we've got yet another version of the infrastructure in place now. Alegria Baquero is got a electronic healthcare record scenario working, and we're pursuing that because we see that healthcare, and especially the use of electronic health records in healthcare, is a situation where there's an ecosystem, doctors, hospitals, insurance companies. There's money flowing around, there's competition, there's risk, there's safety concerns, there's security concerns. It's a very tough domain to have a good solution in, and we think that this focus on it as being an intrinsically decentralized system has some hope for the future. I might say, kind of in contrast to what? In contrast to what would be in contrast to a monolithic solution. So if you had one healthcare provider who handled insurance, all the doctors, all the electronic records, and a patient only worked within that single healthcare system, that's a safer world. That's a world in which current technologies arguably might suffice. But as soon as you step outside of that bubble, things get a lot more difficult. So why are they so important? Styles carry forward this knowledge about things, give you a basis for predictable results, but mostly they provide conceptual integrity. That's the basis. So just to finish, I'd like to acknowledge Eric Ashby from the Aerospace Corporation and Michael Gorlick, my collaborators on this. And with that, I'm out of time, so I'm going to take one question if there is one. Otherwise, I need to. Yeah, John.
It seems to me that would also apply to multi-level classified systems. It could.
Yes. My only concern there is that with multi-level classification, that's kind of a world of its own. I mean, you could certainly support that, but I'm just not a huge fan of the multi-level classification thing to begin with as being a viable approach going forward.